Hi everyone, and welcome to a 3D printer upgrade video, and in this one we'll be printing out a mount for the Raspberry Pi camera module, which you remember I fitted to the 3D printer a few videos ago. Okay, yes. I have to adjust the settings. I've got a bit of stringing here, look, between these two parts where it's crossing over from one to the other. Let's see if we can get these off. They'll break off okay. If anybody's had to do support material before, they'll be fully familiar with trying to dig this out of here. At some point I'm going to have to get a dual extruder with PVA filament, which is dissolvable, and that will print support in PVA, which I can then just dump that into water and it will dissolve the PVA away. So generally it's not too bad. So I'm going to need to do a bit of clean up on that, but we've got all the pieces that we need, and I'll bring you back in a moment once we've assembled it. Off of that. Cool, back in a bit. Okay, we've got it installed. Got our 3 articulations, so we can bend this one up and it swivels clockwise, counterclockwise, and similarly we can go yaw as well, so it gives us enough adjustment. Might need to adjust the CAD a tiny bit. The tolerance on the joints is a little bit off, so some of them are very tight, 2 of them are tight, and 1 of them's very loose, so I might readjust that. You have to think about the placement of the camera a little bit. It's okay there, but you can't see much of what's actually printing, so what I really need to do is get it down at this level so that we're looking in. That might mean a longer arm or something off the extrusion, but I have to be a bit careful to make sure obviously the moving parts don't bash into it. I'm thinking it might be on this corner, but that needs a very long cable in that point, so I'll have to see if I can get a longer ribbon and see how it goes. But for now, yes, this is all done. You can see there's 2 fixing screws which hold the actual Pi camera module inside this housing, and the lens is just underneath there, and it's all rigged up through Octoprint, and I can see this now from my office. So basically I can do CAD, send it straight down to the printer, providing of course there's nothing on the bed and that's all prepped up and ready to go. I can just hit print in the office and away it goes, which saves me a lot of time, and also means if anything goes wrong, and sometimes it does, then I can see that immediately. So great, there's another upgrade for the printer, and thanks for watching for the video. Hang around if you want to see the CAD CAM portion of this. I'll run through that as I normally do, but thanks for watching, and I'll see you on the next video. Okay, welcome back to the Fusion 360 part of this video. And this bit of modelling is going to be no different really than any other than I'm going to whiz through most of it because I had to do quite a few operations. You can see from the timeline at the bottom, actually it goes on for quite a while, and we'd be here for a couple of days if I went through everything, so I'll pick out a few highlights. So anyway, to start the model off, I thought the best thing to do here was actually put the Pi camera module into CAD itself, and you can get the dimensions of the camera module from the Raspberry Pi Foundation, but also I took the opportunity, as I had one in my hands, to measure it with the digital calipers as well, just to check, because sometimes manufacturing on these can be a little out of tolerance, and probably a good idea I did that because it was slightly wider than the dimensions on the Raspberry Pi Foundation website had. So anyway, this was a fairly trivial object to sketch up. I mean, it's basically a square with another square in the middle, and then a number of circles to either extrude through and cut through the body for these holes, or extrude out to give us essentially the lens shape and height off of the board. Also put a piece on the back here, which is where the ribbon connector will connect into, which was very handy because that gave us then a dimension essentially to cut a slot through the back of the, or the bottom if you like, of the actual holder, which essentially is just another sketch. Let me bring those up quickly. So there's the one for the camera, and there's the one for the holder, which is just really just an offset of the outline of the camera module itself. Now you'll notice that they're in a slightly different position, and that's because when I first did this model I made a bit of a mistake by confusing the axes of rotation, and ended up with two axes actually rotating in the same direction within 3D space. So I only had two points of articulation essentially, and you need three to be able to position the camera in any position once you've fixed it to the frame. So there we go, there's the outline anyway of the, or the shell if you like, that's going to hold the actual camera module itself. There's a slot at the front so you can put the camera module into it, and then another slot at the bottom so the ribbon cable can go in there and connect up to the camera module. This piece here was just basically a rounded rectangle extruded out, and then with a hole cut through all the way through, put a construction plane over here, and then cut a rectangle through this down to this plane here, and then also put a slot, another small rectangle just to cut into this piece here. And the reason for that is, if I bring up the next body, and it's handily coloured differently, you can see that essentially you can have a keyed cylinder inside that, and I also made that 0.2 of a millimeter in radius smaller than the outside shape, so that there's a bit of tolerance there, and that pretty much worked okay. And similarly here you've got some tolerance above and below this key so that this can actually fit into this slot, and then you can articulate this around the left and right axis as we're looking at here, so kind of a yaw if you like in this direction. And again did essentially the same shape as this one, just a bit bigger obviously, so we can fix this post to it, and cut the same arrangement into this on this area as I did for this blue piece up here. And that then gives us our next object, which is again another keyed post that goes into this hole, again with the same tolerances, so we've got a bit of play there, and we can actually move this. I did actually have to expand the tolerance a little bit. The first time I did this it was way too tight. You could just about force it together and then it wouldn't articulate without breaking off this quite delicate piece here. And in fact what I should probably do is make this thicker in this direction, so that this piece is actually a bit stronger, but it's held up okay and it's not subject to massive amounts of vibration, so it's okay. And then what we've got is an extruded post, and this is actually a version 2 with a longer post, so I can mount this on the extrusions on the 3D printer that are on the base of the printer, rather than where you've seen it on the video where it was kind of on the gantry, if for want of a better expression. And also extruded a hole in the top. If I just remove that one there, so that this, there you go, you can see that this key here can then fit into a square hole in the top, or a rectangle hole in the top, and fix these two pieces together. And that's quite tight as well, so that's pretty good. You don't even have to glue that, which means you can take it apart again later on if you need to. And all that really leaves us is a base piece, so we can actually affix it to the 3D printer, and that is, as it looks, a big rectangle, a number of circles to do the hole for the M5 bolt that goes through there, and then obviously a countersink just to make that look pretty, bit of a flange extruded up here, and so that this post can sit in it. And you'll notice that the bottom of the post, if I just switch that off, there's this flanged area there which sits inside and locks in place. That sits in a recess there. Then all we needed to do was extrude a piece out, another rectangle, and then cut that through actually when we did that hole, and that creates again like a key which fits into the slot on the aluminium extrusion on the 3D printer. And we're pretty much done. You'll notice though that what I've done throughout this model is I've filleted most of the edges. A, it makes it look a bit prettier, B, you don't have sharp edges, so that's pretty handy. Now the other thing is, because I had to move this holder and the camera to get the eventual shape with 3 axis of articulation, so we've got a rotation around here, a rotation around this axis, and then a rotation around this axis as well. In order to do that, I had to move this shape and the camera and the holder relative to where they were originally on the sketch. Now, the good thing about this is it still maintains the relationship between the sketch and the extrusions, so that if I wanted to like widen these screw holes, which I didn't need to do in this case, but if I did, I could change the sketch dimensions and that would flow into these 3D areas of the model correctly, so it doesn't kind of break the association, which is really handy. So that was basically all there is to this. It's not particularly difficult, although you did have to, it took me, like I said, a couple of goes just to make sure I could get my head around the articulation I needed and where I'd have to put the joints. So as ever, thanks for watching. Oh, and before I go, as with most of the 3D printed objects I do, you can find the Google Docs or Dropbox, I can't remember where I store these things, probably in my Google files or whatever it is called these days, and you can grab this model for Fusion 360 for printing yourself if it's useful. And so thanks as ever for watching, and I'll catch you on the next video.